This video will show you how to create a ternary phase diagram in the iron-chromium-carbon system at 1000 Kelvin using the graphical mode of Thermo-Calc. The calculation is based on example T4 of the examples included in your software. However, this video will show you how to build the calculation so that you can customize it by selecting your database, configurations, and settings. If you want to run the example as it is, go to the Help menu, Examples Files, Thermo-Calc, and double-click on example T4. To begin the calculation, open Thermo-Calc in the graphical mode. There are two simple ways to create a ternary phase diagram, and in this video, I'll show you both. The easiest way is to use the ternary calculation template. Simply click on the ternary calculation button. All the nodes you need will appear in the project pane, and the calculation will mostly configure itself. All you have to do is select your database and elements. Click on the Database drop-down menu and select the FE Demo database. If you have an older version of Thermo-Calc, use the ptern database, and if you are working on your own calculation, select the database you need. Next, select the elements iron, chromium, and carbon. Under Calculation Type, select Isothermal Section. You could also select monovariant lines or liquidus projection if you'd prefer. Now, select Perform Tree at the bottom center of the program. Once the calculation is complete, your plot will appear in the results pane, but I'll show you the second way to complete the calculation before we look at the plot. Click the My Project node, then select the Phase Diagram template. Notice that more nodes appeared in the project pane this time. This is because this method of calculation gives you more freedom to configure your calculation, but it is not as quick as the first method. With this method, you must configure each node. Start by selecting the System Definer, where we'll select our database and elements just as before. Click on the Database drop-down menu and select the FE Demo database or whichever database you are using. Then select the elements iron, chromium, and carbon. The system is now defined, so click on the Equilibrium Calculator node to set the conditions. This is where we have more freedom to set up our calculation. Here we set temperature, pressure, system size, and composition. We will use the default values, so make sure your values match mine. You can change these values if you're working on your own calculation. However, the values must be within the range listed under the axis definitions, so change that range if you need to. You can also change the units for temperature, pressure, and so on, and you can change the composition unit. We also need to select our calculation type, so make sure Phase Diagram is selected. Finally, set your axes to mass % chromium and mass % carbon. Our calculation is now configured, so select Perform Tree at the bottom center of the program. Once the calculation is complete, a second plot will appear in the results pane. This plot is the same as the first one, but the default for an isothermal section is a rectangular plot. To change it to a triangle, select Plot Renderer 2, click on Show Triangular, and click Perform again. Our plots now look similar, but they have different elements on the axes. You can change these by selecting the Plot Renderer node, selecting the elements you want under each axis, and hitting Perform again. We will leave the plots as they are. This plot shows you a ternary phase diagram in the iron-chromium-carbon system at 1000 Kelvin. To see the composition at any temperature, hover your mouse anywhere over the plot. A text box will accompany your mouse showing the stable phases and the mass % chromium and carbon. To see the exact composition, right-click on the plot, select Add Label, then Show Details. Here you can see, for example, which phases are in equilibrium and the composition of each phase. You can also change the text at the top if you want to customize your label. When you select OK, a label will be added to the plot that lists the stable phases at that point. You can also change the title and rename the axes by right-clicking on the plot and selecting Properties. Make the changes you want, then select OK. You can export the contents of the plot in a variety of formats by right-clicking anywhere on the plot and selecting Save As. Your labels and title will save with your image. You can go back and change the configurations at any time to run a new calculation. You can also add additional equilibrium calculators and plot renderers if you want to create additional calculations and compare the results. Each calculation will receive its own tab in the results pane. You can save the entire project to return to it later or share it with others by clicking File, Save Project As. We hope you find this example useful. We are constantly working to create new videos, so check back regularly at www.thermocalc.com.